So we will start now. I'm going to share my screen. We are at currently at experiment 6. Shortest paths. So we get two nodes and we have to model make our code so that we can find the shortest path. And we are going to use map reduce in that. So let's see a brief introduction of what is actually map reduce. This is an image. Let's say this is the input. A good cook could cook as much cookies as a good cook could cook cookies. Okay, so this is one bunch of sentence. Okay, so just imagine some delimiters like comma or something. So that is how we split. So we need the delimiters basically to split our strings. So, but we didn't get in that in the picture. So, so what we do is first we split the input. See, first we split our input, whatever we are getting, in chunks, and then we map it. Like A1, good one, cook one. We gonna map it. We call it a key value pair. Okay. After doing that, after mapping, means after splitting, we are going to see okay, what is the frequency of a particular thing, and then we are going to make key value pairs. And then after shuffling, we are going to take. Purpose of shuffling is to take one unique word and see how many of the occurrences are there. So first, in this case, we are saying how many occurrences are there. So we find okay after shuffling that okay this is A and this is 1 and 1. So this is a key that I'm getting. And while shuffling, I'm not taking a repetitive key. Okay? Key repetitive, I'm not taking, but associated values, I'm going to take again and again. Again. So, and that is I'm going to do with each and every one for each and every word. So, after shuffling, we are supposed to reduce it. So, right now, seeing 1, 1, 1, 1, but in the reality, it would be very much. Okay. So then we are going to reduce it and we're going to take it to okay now this much unique words we have and these are the occurrences and this is a reducing. After that we produce final. So and this happens parallelly. That is why the speed of this algorithm is a lot more than usual. Okay. So let's see what our experiment 6 is. So first here we're going to let's get into the code itself. So it is saying first to create an adjacency list, and then we initialize the distance of each node from the source nodes to infinity, except the source node itself. So I explained to you the last time, last class, that how we are actually able to, remove these warnings. So we are supposed to go to the experiment 6, the whole project, and we are supposed to yeah, where it is build path. Yeah, so build path. We are supposed to go to configure build path, and we are supposed to add external JARs. And in this external JARs, supposed to give here to etc Hadoop. So basically, all of them are Mhm. I can fix this. We'll get onto this later. We'll just around the. So first we have to create an adjacency list. All these are imported because of the packages that we have actually taken from Hadoop. Right now there is some corruption or something. That is why we are not able to see that. Now, if you look to the last video, you will see how we actually do it. So now let's get to this. This is the main class, and we are creating a node. Okay, here we are going to create a list. Okay, so first now it's an empty list, and right now we are taking distance as a maximum value. So it's not Python. So in Java, whatever maximum value you can get of an integer, we are going to associate that with the distance. And this back pointer we are taking for backtracking. So we can go back and we can see, okay, what is the issue. Now we're initializing this, and this is a method to add an edge, and we are adding a new edge with target and weight. This is a public static class edge. So first we are taking target as this string, and weight will be int. And this public edge, and this is actually a constructor. Okay? Which constructor means whenever we are going to initialize, means make an object of a class, some values will be associated to it, initial values. Public static class, mapper class. Here is the step that we are going to map. So created an adjacency list. And what is the next step that we are doing? Is initialize. We have initialized the distance. Now we are creating a mapper function. First, we created an adjacency list, as I said, and then we initialized a distance. Right? That is what we did. Right now, here we have all have this text. These are the data types. You can say, or you can say class. Okay? So you can see this is coming from or.apache group. we have taken from this or this. Most of the things that we are using here are taken from Apache, Hadoop. Okay. Now here we are actually creating our wide map. So first we split or whatever sentence that we have got. We are going to whatever string we have got. We are going to split it. Okay. We are going to split it with tab. With tab. So we will have whatever information we would have in a a text file or something in a string. So a colon b, and this is the distance. So imagining that we are going to take this tab, we are imagining that it is not separated by a new line or something, but it tab. So first of all, we are going to take parts of it. Now node ID is parts of zero. So this has a sample text. Okay, let me just get a sample text. Data D. Yeah. Let's say this is our sample text. Okay, so we can see that this is separated by a tab. This and this is separated by a tab. Then separated by a comma. Then these both are separated by a colon. So we are doing nothing but parsing the text and extracting meaningful information according to that. Okay. So what we are doing, but first we are splitting by a tab. When we split through tab, then obviously we'll get this as one element of list and this whole as one string of the list. And we string as an element of list. Okay. In the next step, what we do, we take node ID as parts of zero. So what will be parts of zero? Obviously, it will be A. So now A is a node, right? Now A is a node. Now, I'm sorry, and A is the node ID. Okay. Now this is our adjacent list. Parts one dot is split. Parts of one dot is split. Is splitting by what? Is splitting by comma. So that means I can say that if I'm saying parts one, so will be parts will be something like that. Zero, and consider that all are strings. Yes, you got told otherwise. So this is what we get after splitting the comma. So after that, yeah. So after that, what we're going to do, we have split it. Now I'm going to take a distance integer dot parse int. So add this list of zero. So it is saying, okay, add this list of zero, whatever it is. I'm going to consider that as my distance. So what do we have in that? Zero. So zero is saying that okay, that is the distance right now for A. Okay. And the I is equal to one. So here we are going to actually go through each node, each adjacent node. So obviously INTI is equal to 1, and we are going to with each element, we are going to go through with each element. So string neighbor info adjacent list. So basically we are going to check for every, because we know that the distance has been separated by column. So we are going to through each of it. And so first is this. So first what will happen as a result of I, so 0. So it is not taking 0. So 0 has been discarded. So we will start from 1. So 1 is B colon 2. So B colon 2 now is as a string, now is splitting it in both in B and 2. So like they have been split, now there is one more split, that is B and 2. Okay. Now B and 2, we are getting neighbor ID as B, that is of 0, and edge weight as neighbor of info of 1. So why we are doing this parse int, we are converting that integer into now int, because it is an integer. Sorry, no, it is a string which has been divided. So let me show you. This B colon 2 will be divided in B and then we are making further split by column. After splitting, this is what it will be. So node is will be now, the node ID will be B, and the distance, the edge weight, sorry, not distance, B, that is actually a distance only, but we are right now taking it as a weight. So weight is now 2. Now context dot write new text neighbor ID, new text. So now we are using this to add this distance plus edge weight plus node ID. So that is just whatever distance we got, we are going to add weights to it. After that, okay, now we have our mapping. So we completed our mapping. Okay, now what we have to do? How we did that? We have decided neighbor IDs and neighbor info like that, and we have divided our data. Okay, and we have divided it into chunks, basically making a list. Okay, now we have to do this reducing is needed. So here it is again declaring it as not maximum value, and string in time pointer right now it is null. Now we are going to iterate through values to find minimum distance and back pointer. So right now we are going to iterate through this value, means this values. Okay, so what are these values? Whatever values we have, we're going to iterate through it into split it. Again, we are making a split by a comma, and then we are getting 0 as a distance, parts of 0 as a distance. Now, again, we are taking back pointer as parts of 1. Okay, now here we are actually checking in this step that whether that how to find a minimum distance. So if you compare any distance to the minimum distance and that distance is less than that, that means that is a new minimum distance. So let's say first of all, our we have taken minimum distance 1 million, okay, 1 million kilometers or whatever. and then I'm comparing my distance, which is 2 kilometers, with this. So obviously this is less. So now minimum distance will be 2 kilometers. Again, it is going to check for the another distance that would be whatever it found. Let's say it is 1.5 kilometer. So it will check, compare 1.5 kilometer less than 2 kilometers. So okay, minimum distance is the distance that is 1.5 kilometer. Now again, it will check for 1.8, let's say. So right now we are dealing with integers. I'm just okay. Let me just take it. So just imagine that I'm saying like 20 and 15. So first it was like 20 kilometers, and I'm comparing 15 with it. And then let's say I'm comparing 18 with 15. Okay. So now minimum distance will remain 15 because this condition is not satisfied. And in every uh, level, the back pointer will be updated. So now we are seeing that parts of 0 is our distance, and this back pointer is parts of 1. Okay, that is how it is arranged. We are just doing nothing but splitting it. And here we are updating and the distance and back pointer. So after this is over, then we are getting the after this loop is over, we will get the final value of minimum distance and minimum back pointer, right? A distance. So now, right now, what we will do? Update the distance and back pointer if necessary. So same thing here. Again, we are going to take minimum distance less than node distance, and node distance is minimum distance. Yeah. So then this we are going to compare with node distance. Okay. And if it is less than node distance, then node distance is equal to then that what we took is what the minimum distance and back pointer it is. Again, we are going to this context that you're seeing. Again, it comes from Hadoop. Okay. And okay, now this is our main function. So it is nothing. We are creating a job variable. Now this is these are all the job. These are all the classes that are imported from Hadoop. Now what we are doing is set jar by class shortest path. Here we are creating our map. Here we are calling reducer class. Okay. You can see this is the shortest path, and these are the classes. Okay. Mapper class, the reducer class. So first of all, we call shortest path, then mapper class, then reducer class. And this is where we are actually printing our not printing. This is actually where declaring our output key. So this is done. We are supposed to do some things like this is shortest path. So we are supposed to export this jar file. Okay. So wherever we want. Okay, where you want to save it, it's up to you. So how we'll do it is jar file basically contains all your experiment. So right now I'm just overwriting it. Okay. So here in so this is basically, see, now you can see the time 1849. So right now it is updated. Executable jar file. Yeah, so this is the executable jar file that we have. Okay, this you will import and you will use this file to actually check the input and because of that input, what output you are getting. So let's say I want to start. I want to run this. I will have to start Hadoop. Start how we start Hadoop is I start DFS first.cmd. Writing this means DFS is starting. And after that you can see okay JPS. Now in start yarn. So this is just specific to the Windows, okay? So it will be in sync of whatever we have done here for evaluation. Sorry, for installation. Yeah, in the last class. So this is done. That means the loop has been launched. So now we do that. After that, what we'll do is we will go to the root directory that we're going to this. Hmm, just going to write it one line only. Okay. CD Hadoop. Okay. So in this, let's say I want to create one directory there. So how will I do that? So I will create two directories. Was for input and one for output. Okay. So fs what is this for? Yeah, mkdir. So I'm afraid that I lost some files due to corruption that might be not be in well sync. So it might not run, but be wary about whatever commands that I mean. This is the process that you will do. Okay? This is the process that you will do. Okay. This and this. Let's say I want to create one, one directory that is practice for test path. In steps. SP input. Okay. We will create for input txt, but we are not going to create for output. the time of running we are going to create our 6 txt. Now I saw that. Okay, so this is where I created. This is checking what is the issue here. So we have one text file, and we have that text file as empty. Okay, the text file as empty. So right now, if I want to copy something into it, how will I do that? So this is Hadoop fs minus put. Now I have one file. I showed you that, right? This 006 file, and we have that in. Going to copy the path of it. Yes. So now I'm going to check it. So right now you can see the size here is 0. Achha, this is just check whether that is asked or not. File is copied. Just minus 10. Exactly, but this is how you copy. There's a little bit issue with this right now. So, but this is how you're going to copy the context of a text file in input file of this whatever path you are given, and then when you're going to run, then when you're going to run the program, where you're going to run with that jar file and the input file and this and the output file. So we have that output folder. At the time of running, we are going to just add one output.txt. Like CFS, what some we have a jar file. We're going to mention our class name here. Class name short package package 006 dot response dot class name, and the second will be the path of the output. Let's see. And third will be the input and the output. This will be input, the input file, whatever contains the input, and this is our program here. This is our class name, and here will be this, right? And here itself, we are going to create one, write one output dot txt. Now it will there are like any commands and that's c dot jar. Jar. idea is to take treat this input 006.txt as an input file, and the output should be copied into output.txt. So, but this is what we have to do. All right. So execution and everything you will be able to do. So this is how you will implement it. Okay. This is the procedure. So because of some corruption in my file, so we're not able to get the desired result right now. Because my Hadoop is corrupted. So is this implement friends of friends algorithm. So let's say there are so many friends, there are too many friends, and we are trying to design an algorithm to get the common friends and then get the sorting them by the number of connections. So calculating the common friends and then by the number of connections we are going to sort them. So this actually has two problems. Right now we won't be able to do that. There's some libraries we used to do that. So in build path, configure build path. So there is some issues getting there. So basically here you'll add all the jar files you're supposed to. When I have those jar files, so I not just so from here you will take all those. I want you to do something. Let me add some. So on work is at all. So our first job is what? First job is to get friends of friends. Okay. Calculating common friends. Okay. So we'll create an adjacency list. Each node is a graph. Then we'll create a mapper function, then a reducer function, and then post mapping this job. Okay. So let's see where our those things are. This is our string tokenizer. This is just initialization. So we'll just take iterate our own friends. Here we are adding a friend. If that friend set doesn't contain that friend, then we are adding that. So if that is not already there, we're going to add that uh, to the friend set. Okay. Here dot set user and friend. Okay, fine. And here again we are using that context that we took from Hadoop. Again, this is our mapping basically. Through this mapping, we are making a list, the common list. You can say Python how we used to do that. We used to use dictionary, but in this, just understand that tuple inside the list. Curly is the curly brackets, or you can say the double dimension list. So we're taking all those things in one list, and then we're making a group of them. So common friends. So basically, it is checking what so it is iterating through all the friends, and it is checking okay whether in that group the friend is present or not. If it is not, then we add this. If it is present, then it will omit it. Here we are going to use the reducer function. So there we mapped. Okay, we may mapped all these things. We put all those friends together with one person based on one person. That is how we map. And here we are going to take common friends. Here we are actually going to take common friends and then we are key them as key and pair. So basically emitting the friend pair as key and the list of common friends as well. Okay. So, what we can say is that there is one friend, let's say that is some name I named Akash. How many friends he has? So he has the list of that. The list of those friends is associated. That is how we are going to take common friends. So it is just nothing. It is, if you see in a layman's way, that you're getting a group of friends and you're getting, okay, who is the friend of whom. And then you're taking one person, let's say Akash, and you're saying, okay, these are the friends of Akash. The Shushma, these are the friends of Shushma. Okay. So through every person, there is a list attached to it. Now, this is the main method. Main method is nothing, just we just going to call whenever we need. We're just going to call those methods. Right now, what we're going to do. So first of all, we configure into create one job variable, job instance. So basically, here is what we are actually doing. Tokenizer. Here we are doing mapping. So here we are just we're just setting a jar file containing the mapper and reducer class. Okay. So here we are just doing superficial things. Here we are doing the mapping, okay? And here we are doing the reduction. So in our mapper reducer, There are only two main steps. First is this mapping, and second is this reducing. We split our data and we map it, and then we shuffle and reduce. That is what we do. That is what is happening here. After that is done, what is the second job? What we do in second thing? So when we have a mapper class. So we right now, what is our target? Sorting the number of connections. So create a mapper function, then creates a key value pair from the first job and emits a key value for each node identifier in the value list. The key is the node identifier of a common friend, and the value is the tuple containing the node identifier of one of those values. Let's get into this and see. So this is our so this is where we are mapping our. Let's get to the main function. So we is creating one job instance again in the jar file. Here we are calling this whatever we are getting here. We are calling this file tokenize mapper. So basically, we are using this tokenizer mapper to tokenize and map our you know whatever data we have. Okay, so right now, what we had one person and a list associated with that person. That is what we have, right? So this is the map function. What we are doing, we're doing nothing. We're using this string tokenizer, and we have just converting that the whole thing into now tokens. Okay, so with this string tokenizer, we are getting this value to a string as a uh, in the form of tokens. Now we are going to take this string friend count, right? Add dot next token dot string. So through this split again, we are going to take the get the count. So basically, what the first value of the string will be the person, right? That person who was associated with all of those people. Okay. The second would be the list. So now where dot send this. So again we are broken down to chunks. Again we have a lot of data scattered everywhere. So in reducer class, we're using queue here. Is like going to compare with text pair one and then we are going to return. So adding text pair to the we are going to use that priority queue in this. So using this priority queue, we are going to sort our common friends. Okay. So basically, the thing is the key, the key component of this program is priority key. That is first in first out operation. That is a big data type. Getting into that would require a lot of time. The next experiment that we have page rank graph algorithm. So what actually it is? Just a minute. So let's see what our experiment 8 is. So the question was not as much clear. So I will just give you an example. Okay. So let's say there's a giant list of web pages and their connections. Okay. Now each mapper takes a small piece of this list and looks at okay at one page when the web page at one time. Okay, it then figures out how much page contributes to the popularity of the pages it links to. So basically, there is one web page and there are many links to that. So it has a lot of links and that has been connected to a lot of pages. Okay, so if a page has three links, it might say each of these links get one by third of my popularity. Okay. So now this is what mapping is in this. So right now, what our target is, we are going to check the popularity score. Okay, what popularity score it is. So let's say I have to rank some web pages based on the popularity. Okay, I have to rank a certain person based on his popularity, how much connections he has made. So that is what ranking is. Okay, so that is how we will. That is what we are going to do in this problem. Like now all those are gone. So what we're doing in this, basically again we are going to parse a string and we are going to take information from it. So first we'll parse its tag. That means there is a considerable distance between one node to other information. You can say one string to other information. We have separated it by a tag. And then that's how we are going to get the node. And then we are going to get the neighbors. So neighbors, how will get parts of one dot split. So obviously, I told you that when some to list a string is now split by a tab. So now that became a list, and that list contains two strings again. So first string will be given to that node. That will be the previously used to take node ID, but here it will take as node or something. So, and the next now parts one dot split again. It is a again that whole string is again split by a comma, and again it is comes into neighbors. Okay, as I said, let's say this node is one website. Okay, one website name. Okay, and what are the links that are associated with them? So let's say you have a website yatra.com or anything, some IRCTC or some flight number, anything is associated with it. Okay, so that will be in the separate list, and those will be called as neighbors. Emit contribution to each neighbor. Now we are going to emit that contribution. Okay, whatever it is, we are going to give it. This is what our mapping is. So basically, it is doing nothing. Every time it is dividing whatever information it has, it is parsing that and it putting it into some kind of data structure. Be it in priority queue, be it in mostly we are doing it in a list. Okay, so that is what mapping is, dividing our the data. So now our data has been divided into key, value, and it is able to, the for computer, it is easier to, and especially for the Hadoop system, it is easier to go through it at parallel at the same time. It is easier. Okay? So it takes, you might not realize that, but it takes a lot less time for a computer to go through this map reduce function. Because when we are mapping and then we are reducing, when we are mapping and we're dividing it into a number of chunks at the same time in the parallel, when you see this, all these are parallelly, dealt with parallel. So let's get into this. Accumulate contribution for neighbors. So what we are going to take, whatever contribution you had, I'm going to add that notes, notes dot add value to. So I'm just taking a random formula. Okay, double new page rank is equal to 0.85 into nodes dot size. So whatever, let's say I have 10, uh, you know, I have 10 websites. Sorry, I have 10 websites that are linked to me, to my website. So again, that page rank is being divided. New page rank is 185. Make note with its new page rank. Now again, I'm going to, now this is the double, so it won't be an integer. Now this is our main function. It is just doing nothing but calling this mapper and then this reducer. This mapper and this reducer, these are the main things, and also this, by class. We make set jar by class. So after you do this, always remember to do this. Always remember to click here and export this in some kind of jar file. So when you do this, you do this next. Click on this and then give a path. Give a path, and you will store your ZAR file. That ZAR file that you will store, that is actually your program, and you're going to run that program through taking the input and copying the output into the output. That is what. Now, we have the last one, that is semi-join. I'm not going to again, take all those addition of ZAR files. Just consider that there are no, if you're not running it. So consider that there are no warnings. So once I actually do this, once I actually take those R files, there will be no more warning signs. So in the layman's language, let's see what it is I may have mapped it. Let's see that, okay, I've taken an example to edit this. Not semi-efficient semi-join. What it is doing, having the mappers load a Bloom filter from a distributed cache and then filter result from actual map reduced data source by performing membership queries. Okay. Let's say we have two data sets, one containing the list of customer IDs and their associated information like name, address, and everything. And another data set containing list of transactions made by customers, each transaction identified by a customer ID. Okay, now you see that we have a customer ID and we have are associating that with name and address. Also, we have a data set that is list that is having a list of transactions made by customers. One customer Yeah. So one customer is associated with also his name and address, and also it is associated with that your number of transactions that is done. So here we are performing a semi-join. What we are going to do, we want to find all the transactions made by customers whose ID exists in the first data. That is why it is semi-join, not fully joining. We're just semi-join. Why? Because we are just considering the first list, the first data, and let's say there are a1 to a10. There are people a1 to a10 in the first list, and in the second list there are a1 to a5, and and then after a21 to a40. But the common people from the both lists are a1 to a5, so those will be considered. That is why we are going to mix. We're joining the transaction data with customer database, customer ID. So this is just an example. That is what our single join is. So why are we creating a Bloom filter? Basically, so we are creating Bloom filter from a data set containing customer IDs. This Bloom filter makes us, it's a kind of a magic that is helps us determine whether a customer ID is from transaction data set. So we have two data set, right? So it is naming it as one as transaction data set and one is customer data set. So what is customer data set? Our name and address and everything. Okay. What is transaction data set? Whatever the transactions have been made. So from a transaction data set, whatever might be in the customer data set. So I am going through transaction data set and I'm checking who customers, who are those people in the transaction data set, those who are present in the customer data set. Okay, that is what I'm doing. So it happens. So Bloom filter just uses, we are using Bloom filter just to get that information. Okay. Action happens. Here we are initializing our filter. Yeah. Here basically because of this Bloom filter, we are going to read Bloom filter. So this whole Bloom filter is responsible for checking which data is from which customer is from which list. Basically, it is checking the synonymity. Checking the synonymity of a particular customer, whether it is in transaction, whether it is in whether it is in the second list or not. So just customer example is just an example. So there are two people, two lists. We are checking the whatever if there are 10 columns, there could be 10 columns. So whatever the commonalities are, whatever commonalities are, via which we are going to join both two lists. Okay, that is what we are going to do with Bloom filter. On here again, we are splitting with a comma, and we are going to get the key and value. So that is how they are separated. this is having a sample data set, then this will have a sample data set. So now, after that, when we are taking that record key and value, then we are going to check, okay, whether this, so Bloom filter has said that, let's say A1 to A5 people are there in, and from transaction list are there in that customer list. Now it is just going to check, it is just going to do nothing. It is just going to check whether this, you know, if that record key that is taken, it is present in that, Bloom filter or not. A1 to A5 are present, rest of them are not present. Okay. So if it is, then output key set record key. Output value set record value. So I'm going to get into this. So again, we mapped our function and scattered. We mapped our whole data. So we got some A1 to A5 and then we mapped in output keys. Okay, these are the people. We are going to reduce it. We'll be using this string build. So since we've got that output key, and this whole part, is this, the whole part is no filter. This is the whole from here to here. We are just mapping, doing nothing else. So now after everything is mapped, we are going to do reduce. So now we have some output values and output keys. So this we are going to take output value with a new text now. That is the initialization. Here is the reduction happening. We are taking this higher exception and just the providers. So again, we are running a loop through the values, and we are going to append this with a string and with comma. In output value, we are copying that. And this is our main function. So the whole mapping that is in this problem is done by Bloom filter. Basically, the Bloom filter, it checks whether one particular list and the second list how much common it has, and then then it maps the data. Then the reduction happens. In reduction, what we'll do? In reduction, we are going to check whatever the whatever see we have common people, and now everyone is mapped now. Everyone is mapped now, and now we are going to take common. Okay, that is our reduction. So basically, that is what we wanted. That is a reduction, and then after reduction, we are going to get the result. So that is next is, since my Hadoop is corrupt, so actually I needed to install it. So the corruption of Hadoop. I will show you step by step how to actually do that. Since there is a correction, I'll take a help of a video. So when you go to download this figure, so let's say I want to, so I go here. Okay, this is the website. So now I'm not able to understand what actually it is. So what I'm going to do is, from here I have to do is, we're not going to get this will get release page. Go to release now. When I click here, button here, directory I'm going to click next here. Okay, so you understand the sequence. That is what is shown in video. So before that, it has not shown. Okay. So in this, what you'll do, so you'll see basically, it's written that see about tar.ch. So it is so many. So just look at the biggest. So it will be around 200 MB. Sometimes it is 150 MB, 200 MB, something like that. That would be the size of the file. So here I'm going to download it. So this is dumping down. I'm going to run. So we already have Hadoop. So Hadoop is necessary for this. Okay, and proper it should be working properly. So right now in this it is shown weirdly. So I'll just show you what you have to do actually. So basically open this with WinRAR and extract this, extract to whatever file system you want. Let's say here. So just extract it here in Windows C, or just doing it in data was told, but data deep was because I don't have space in this Windows C. So don't do it. And always paste in this application will always paste in C. Better to do always in C. So data D. Let's go through this. So basically, that is what you have to do. You have to extract it. So either you extract in Linux by using that tar command, okay, or you do that. Okay. After extracting, what you're going to do is you're just going to edit the system environment variables. And whatever path it might have. Whatever path it might have, you should be like in my, I've given D, so I will give D. Then it, so it has done that. And after it clicks on path. So right now I've created one system variable, then it will click on path. Then it will write like this percentage pig home. Then it myself. How to set environmental variables? Go to env here. Okay, and now get new. Okay. And here I have created this pig home. I have created. Okay. After that, I clicked on path and I edited the path. So percentage of pig home. Okay, so everything is fine. So the Hadoop won't able to be able to run, but it will show you how it will run. So in this, you will write the lib exec. So library execute. Okay, execute. We are going to change that pin to. So what we actually did here in our this file bin, we have three files. So this Windows command that you're seeing, this is actually our this is the file that we're going to edit. So this bin we're going to okay, it is what it is going to do. Okay. Now, if I want to set my, I'm going to save this. I'm going to minimize this. Now, if I want to change the path, now obviously, I mean, I have taken this, so why not change the path? So I will copy this path and I've changed my environment variables. So environment variables, system variable, taken this big one, edit that. I will just edit the path. Those statements. Okay. That puts second thing. Now there comes the path. Big home dash big home dash big. So it doesn't matter. I don't need to change this because I have already mentioned big. Okay. Now, since I've done that and changed this, it is supposed to be. It is now. It is now installed. Now I'm running command prompt as administrator. Able to see this. So you can just write big and you can understand whether it will work or not. It is not reading, but you see this is saying that it will work. That's because some of my systems are not doing my files are corrupt. So this is what you should get. So you will get this line that the pig script ID for the session. Get this line. is installed. On that, you can use multiple SQL statements. Let's come to this Hive. So Hive I've done, but I'm going to, since it's not working, so I'm going to show you how we are going to actually take it from scratch. I'm going to delete this. So now, what I'm going to do now is basically here, there's no link for download, I can see. So I will just go to download.apache.org. Okay. Here, what I'm going to do, there are too many things, right? What I'm going to do is ctrl F5. Okay. I've got Hive. I clicked on Hive. And I want to take, now these are the versions that Hive has. So let's say I want to take 3.1.3. Clicked on it. Now, which of them I need to take is bin.tar.z, gz. So you can see this 312 MB. Okay. So this is what I'm supposed to download. So I can also take this. It is a little less, but let's do that. So here I'm going to download. The clear means I can. So it is downloaded now. So it is always better to open through WinRAR. What happens is it's easy to extract. So wherever I want to extract, I want to extract. Wherever I want to extract, I will just go. So I don't have space, I'm just going to put it here. Okay, let's see. Another mesh. So parts of word. So this is what we have. We are going to name it, rename it as easier for us to track, nothing else. Okay. Now this is what we got. Now we have to do one more thing actually. We have to download Derby. So already have that. If you want that, so download Derby. You have this is also belong to Apache MQ. So how we'll do that? Do this. So for running of Hive, two things are necessary. One is Hadoop, and the second is Derby. It depends on your Java. Okay. What Java version do you have? If you have Java 6, then this. If Java 8 or higher, then this. Okay. And so on. Okay. So you must check your version of Java first. How will you check your version of Java? You have to do nothing. This Java version mine is Java 8. I take this. If you have just checking here what this is mean. Where 8 is the version number and 1 is the version string. That means we have Java version 8. So if we have Java version 8, then what we are supposed to do? We are going to download this emoji. And here we are going to download this one, the first one. Again, we got a zip file. Now, again, we have an issue now, right? This is a zip file. 2.8 with WinRAR. So whatever will be, whatever will be extracted, I'm just going to name it as Delphi. So whatever I have done, it's already done. Okay, I already have that file. So in this file, what I'm going to do, I'm going to go to this library. I'm going to select all this, copy this. I'm going to paste that hive. So here is our hive. This is our hive. Here I'm going to paste in library. These are files. Get one of this. RBL. Hive is. So now, let me show you. So so you don't need to see all this. We done this. So here we are going to set up the environment variables. iPhone and whatever path it has. Then hive lib and this, and then one more hive bin. show you that it is in my folders. So, see this. I've been, I've lived, I've gone. So that I've taken. I've been. So in path, what we're going to do, we're going to take the bin path and the derby bin path. Okay. After that, we're going to do one more thing, and that is this Hadoop user class path first and the variable true. And we're going to do that in both of the cases. Now, all that is done. Now, on this derby home. Now, how will I get the path? I'll just go here. Just going to take that. See done. Next step. What I said. User class path first. You're going to take that in both of them. Then you're going to edit the path. I've been, derby bin. Showed you that way. You have to go here again. So these are my variables. Let me see that derby home not here because I forgot to click. Okay. So again, I'm going to take this and we open user class path. I've been, I've opened, and then here also I've taken Hadoop dot user class path. Again, we have on paths. I've been derby. Again, I'm going to just cross check before getting into that whether everything is there. Okay. Now there is one more issue that is XML file need to download it. And we have to put this, we have to put this in your Hive, this folder, Hive conf. So here you must be seeing that we don't have that. So we're going to do, we're going to take this from down. We're going to move this. You're going to move this to Hive first. Just going to move it to Hive. Now in Hive, we have Hive side. This that is complete. System is ready. We check. Okay. Now, those are this. So for actually starting Hive, you need to start Hadoop. Start Hadoop. So what? How will you start Hadoop? We start DFS. DFS dot cmd. Hadoop is working fine. We start yarn cmd. Now our Hadoop is in action. Second thing that we have to do, we have to launch it Derby. So there is a command for that. That is, let me see. This is the command for launching Derby. So when first time you do that, there will be there will be a pop-up, and Apache will ask you whether does that have permission to, do you want to allow permission for it to edit it your, I mean, edit your computer and anything, files. So you have to allow them in order for this to run. Okay, so now this is open. I will minimize this and I will open this command prompt. You have to open this always as an administrator. I'm an administrator, but always run this as an administrator. So here you will write Hive. So I will not do. So in by clicking JPS, you can actually check whether your Hadoop is working properly or not. Right now I've started this server, so you can check that. Yes. DFS dot cmd JPS Start here. Yep. We can start our network. That is what we have to do. So that assistant won't do the same things. So all you're writing is Hive. So after you write Hive, this is what you will get. Basically, you will get a connection here, yeah, connected to Apache Hive server. It is not working because a little bit an issue. Otherwise, this is how it will behave. After that, when you get this connection, then you can create database, and then you can perform all your operations. It will basically show you live, and in that it will run. Your Apache server will run. On that you can work. Sorry, Hive server will run. So all these operations that you're seeing, you can perform over here. Get database, the database and everything. All the SQL statements. Our as that will be all. Okay, thank you very much. Are there any questions? You can ask any doubts if now my system on my system it was not running basically because of some corrupted files. But this is how same fashion you have to do. You have to download it. The first thing, you have to extract it. Okay, the second thing, and the third thing is that you have to set environmental variables. Yeah, one thing more, I didn't actually send you that file actually send you that. So this is the XML file that I'm sending you, that you have to actually put in that conf folder of Hive. That will be all.